and all. Good morning. The subject name is compiler design. In this, we have discussed several topics and the phases, important phases of compiler. Now, we are moving to a new topic, that is problem solving in the first phase of, that is compiler design, to the end of the phase of the compilers. That means we know that there will be several number of phases of compiler design. Lexical analysis is the first and foremost important phase of the syntax analyzer, semantic analysis, okay, intermediate code generation, code optimization, and code generation. Now, here the example. What is the different phases that collects different forms of outputs by collecting the entities. Now, in the first phase of the compiler, the starting phase, that is lexical analysis. So, how it identifies the corresponding things in the phase of that is lexical. So, it separates the source language program into different forms. So, what is that? Identifiers, comments, numerical, constants, keywords, lexemes, and arithmetic operators also. Now, suppose for a given program, how this, suppose hash include std.h, integer max of x comma into y, if x greater than y, return x, else return y. Now, in this process, we are going to give this program entire as a input to the lexical analysis. So, lexical analysis is the one which performs the separation of these things. So, how it will separate means, suppose hash include std.h. So, it identifies that it is a preprocessor directive. And int, if we consider, suppose here this is the hash include one. Next one is, it is taken as, it reads the character, first character, then it reads the second character, then reads the third character, and another space identified. Then it completes. It says that it indicates that a lexeme is to be identified. So here, what type of it is? It is an identifier, comment, constant, operator. What it is? So after completion of this token, then this is to be identified what lexeme it is. So it is lexeme, integer lexeme, and the corresponding one is token is considered as a keyword. Token is considered as a, like that. Maximum also it will read character by character and identifies that yes, maximum is an identifier. Maximum is an identifier. Maximum is an identifier. Int x, so here left parenthesis. So left parenthesis are also taken as one of the operator. Then int is also written, that is keyword. Then x, what about x? X is an identifier. Then comma is also considered, it is an operator. Then int we have considered already, it is a keyword. Y, what is y? It is an identifier. Then open parenthesis, open brace, that is to be considered as an operator. Then this double slash followed by this will compare two numbers. So that is to be considered as a comment. What type it is? Comment type. and some of them are tokens and some of them are non-tokens, like preprocessor directive, comments, macro symbols, and white spaces. All these to be considered as a non-tokens, whereas the identified lexemes are to be considered as a token. So in this case, x greater than, if suppose in this line, if is a keyword, so it is to be written as a keyword, and left parenthesis already written, x is taken. Greater than is an operator, so greater than is considered as operator, and y you have considered already, it is an identifier. Right parenthesis also it can operator. Return, it is a keyword, and x it is an identifier, and semicolon it is an operator. Else keyword, open parenthesis, open brace, curly brace, it's operator. Return keyword, y identifier, semicolon operator. Right curly brace, it is an operator. So like this, it is going to be identified. The source program, it is to be considered as a whatever the program that is to be given, which is in the source language, like the statements. What is the statements? Like hash include std.h. Suppose it is a C program or C++ or Java program, any program which contains a series of sequence of instructions which is given to the compiler for execution purpose. So it will generate the machine code and we are going to get the results. So at the initial step of this phase, the first line of code that is to be available is that is to be considered integer max into x comma into y. Like this, these statements are to be kept as a source program instructions. So it is a high level language. So computer can't understand this high level language. It converts to the compiler a high level language into a machine code. So this machine code is to be processed with the help of this compiler first phase, that is given to the lexical analyzer. Lexical analyzer is the part which accepts this program and generated a set of lexemes, tokens, identifiers, keywords. Like this, it separates the process of this one and generate this one. So this is the motive of this first problem, where it identify the set of comment. What is the hash include? Is it a processor directory? Is it a macros? Is it a constant? Is it white space? Is it comment? Like that. What is a token? It is a non-token. Like that. Operators. Everything can be each to be identified, processed, and separately. Now, the second problem, which we consider the most important one in this phase of the compilation process, that is what are the steps, output of each of the phases of this one. For example, if you consider the statement I equal to I star 70 plus j plus 2. I equal to, where I and j are floating point numbers. I equal to I star 70 plus j plus 2. So this is the programmatic statement, one of the assignment statement if you consider. Then when you apply this each of the phase of the compilation process, then at the end of the out of all the phases output, we are going to generate the output of all the phases of a compiler. So we know that different phases of the compiler. So first phase is lexical analysis. So in these phases it identifies. So previously we told that it separates the instructions into each one separately. That means what is it is going to write down the notations, what I star 70 plus j plus 2. Now what is I? It is an identifier. J also identifier. It consider it. So it identifies the sum of the sections. So identifier I and j are the identifiers. Star, it is an operator. Plus it is also considered as an operator. 70 constant. 2 also constant. So like this, it separates all the informations. This is the assignment operators, tokens, lexemes, non-tokens, header files, constants, comments, like that. In this given statement, what are the things that is available? It separates, identifies, um, and then this output is sent to the next phase of the compilation process. What is the next phase of the compilation process? Syntax analysis. Syntax analysis, it is going to construct a parse tree notation where the nodes are to be considered as operators, and remaining is considered, that is left and right is identifiers, like that. So now in this example we are going to construct a parse tree of structure. So I star 70. So if you consider I star 70, star is an operator. So we are going to write star as operator. It is, so if in this while construct the parse tree, the observations are, nodes are to be considered internal nodes. Internal nodes are considered as operators. Internal nodes considered as operators. And the leaves are to be identifiers, like that, tokens who can represent the information. So here we are going to consider plus star is an operator. So since star is operator, what is the left? It is an identifier. So we are going to write I. And what is the right of this one? So 70. So we are going to write right child of this star as 70. Now if you consider this plus is an one more operator, if you consider plus is an operator, then the left of this what is available and right of this what is available. So left of this plus operator we got I star 70, so which is given to the right left of this. So I star 70 already calculated. So this is to be attached this to the plus operation, plus as a left child of this node, whereas a right child of this node, that is j plus 2. So that is here in j plus 2. What is the internal node? Plus is an internal node. So that's why you are going to write plus. To the plus, right, left is j and right child node is 2. So if you consider j plus 2 as a one right child, then to this plus node, internal node, once again internal node is plus, and then. So this is the form of construction of the syntax tree. That is also called syntax tree. So whatever the code that is represented in this statement can be separated into different parts of the units, sections, and once again this is to be constructed with the help of syntax tree notation. Now the output that is generated here, that can be sent to the next phase of the compilation. So here in the compilation process, next phase is semantic analysis. Semantic analysis means here it verifies the each and every type of that particular object notation, whether this 70 is to be considered as int or float, this 2 is to be considered. So we are going to determine each of the types, and it verifies the semantics of that particular language. So syntax and semantics are to that is semantics of that particular verification done by using typecasting. So here 70.0 and 2.0 can be, so it is considered as float. Since y and j are given as float numbers, so 70 is to be considered as float numbers 70.0, and 2 is considered as 2.0. So this is to be as a writing part. Here it will determine the float of 70 and the float of 2.0. So that is to be considered here in this case, and in this that output is sent to the next phase. What is next phase? Intermediate code generation. What is the next phase? Intermediate code generation. In this phase of the compilation process, the output that is generated is a 3 address code notation. That means here we are going to use a temporaries. We are going to use a lot of temporaries, required number of temporaries as per the source program instruction. So we know that that is I star 70 plus j plus 2, I equal to. Now this first initially we are going to perform this operation with a temporary, say t equal to I star 70. So that means here first the 70 is to be evaluated with integer to float representation, and that's 70. Then this is to be multiplied with I star T1. So again we are going to take another temporary T2. Now once again the 2 is to be taken as one more temporary. Say that is, if you write T plus 2 and T4 float into float of 2, that is float point 2.0 will get. Then from this we are going to get T3 plus 2, T3 plus T4. So what is T3? J plus T2. So that T3 plus float value 4, we are going to get the result assigned with new temporary. Now what is totally equal to T5, that is assigned T equal to. So here T1 is one temporary which is used for the assignment of float value, and the multiplication of this one is to be assigned with some temporary, and this addition, the previous value with the addition of J value is to be stored in another temporary, and float value 2.2 float value is stored in one temporary, and previous two values are to be added with addition, getting the sum result that is stored in one temporary, and the final result is stored in one. So like that we are going to use different temporaries of the variables, and then these two to be calculated each separately, and total result is to be identified process. So that is the main important phase of the intermediate. So that means a code is generated for each of the statement. A code is generated, depends on the 3 address code notation format. So then this code, the 3 address code what is generated by the intermediate code generation, can be sent to the next phase of the compilation, that is called as code optimization. So here the code optimization, see I star 70 plus J plus 2. I star 70 plus J plus 2. Now, what is the code optimization that can be done here? Previously, code is generated with a lot of temporaries. Now, we are going to reduce the code with the help of this phase. That means, here we can perform I star 70 and store this result in 1, and this X plus J and store the result in some Y, and Y plus 2 we are going to get the result Z. So, the number of lines of code that is reduced, lines of code is reduced, or reduction happens in this phase. So lot many number, that means we are going to remove some unnecessary lines of code, and repetition of the any avoidances, any common sub expression. Lot of techniques are also there. We discussed this one based on the implementation of this algebraic transformations, and this one. For this step, it is only one assignment statement. We have get these 3 lines of code. So, if there are many lines of code in the given program, then definitely we'll get a lot of lines for this source code. So that's why in order to reduce that numbers, we are going to use these techniques and then shorthand this one. So optimize the code which gives the better results and program runs faster. So that's why it is. And then the next final phase of the compilation, code generation phase. Here in code generation phase, we are going to use registers along with an instruction format. So generally the instruction which usually add, move and subtract. So here first we are taking one register, one R1, and say the value of I which is moved to, that is source to destination, that is I value. What is the I value? That is to be register 1. Then multiplication, we are going to multiply with 70. So multiply with 70. What is the register? The previous holds the value in register 1. So that value is to be multiplied with 70. That value is multiplied with 70. So R1 dot 70. R1 dot 70. Now We'll take one more register for the purpose of moving the float value with again. So that is R2, which is the value of J. So that is move J comma R2. Now we are getting some register. So register is to be added with previous. Previous means what is the R1 dot that is star 70. So that is to be added to the register R2. R2 is one more register. So that is with J. That means we are taking one more register and move the contents J. Now R2 holds some value, R1 register R1 holds a value. These two values are to be added, R1 and R2, by using the add instruction. So here we have added with R1 R2 and result is stored in R1. So now that result is to be added to the float point number 2.0. So here the hash indicates that it is a constant value which is to be represented in the instruction format. So hash 2.0 comma R1. So now R1, this is add the R1 plus R2 will get. The result is stored in R1 and then this R1 is to be added to this 2.0. We'll get the total result. So in this way, mnemonic instruction formats, assembly instructions are to be delivered in order to generate the output of the program. Output of the total program. Output of the program means here in this program we have given one assignment statement of the format. Like that, several assignment statements of the format we are going to give, and that is to be. If you take one more example, that is the count total equal to count plus rate star 5. Now each phase how that is to be written. That means the total equal to count plus rate star 5. Now what is the lexical analyzer phase? What is the lexical analyzer? What is the output that is generated by this lexical analyzer? So it will identify what is total, what is equal to, what is count plus rate, star and 5. So it is considered as an identifier, and equal to is an operator, count identifier, plus is an operator, rate is an identifier, star is an operator, 5 is constant. So like that, these details are to be separated. So we are going to write the what is identifier. First one is an identifier, total. And equal to, what is equal to? Equal to is an operator. Next, third one, it is that is identifier to second identifier. Now plus it is an operator. Now plus is an operator. Next, rate. Rate is an identifier. One more identifier. ID comma 3. Next, star, it is an operator. Next, 5, it is a constant. Rate star 60 or 5. So here whatever it may be the constant value, we can represent 5 or 60. So that is to be represented. So like this, the information is to be separately written with the corresponding. So this is to be sent to the next phase of the compiler. So here it will construct a tree. So we know that the structures of the positive notation where we can use. Like this, the symbol table information also, it is to be maintained inside the that is left side we are having symbol table, right side and handling mechanism. This each of the phase has to be noted with the different values, the corresponding information, and this side symbol handlers, error handlers are also to be there. Where any errors are to be there, then that is to be processed with the each of the compilation process. So the cell handlers are to be used for the rectification of any errors for each of the phase while going the processing output. Now the second phase syntax analyzer is going to generate a parse-tree notation. So that is parse-tree here equal to what is the identifier 1 here, that is to be considered identifier 1. And identifier 2 is to be considered. So that is plus. So here plus identifier 2, left child of this node plus, and right child we are having one more star, and then identifier comma 3, and here constant, that is 50, which is to be represented. So this 60, 5 or 60 This is to be processed as a syntax analyzer process. This is the parse tree which is available generated in the syntax analyzer, and this is given as output to the as a input to the semantic analyzer. Semantic analyzer performs this task and resolves the all the issues. So here it resolves that integer to float, into to float of 60, into to float of 60. Now we are going to draw syntax analyzer with the notation, how the appearance each of the phase. Now this is the assume that this is the syntax analyzer phase in the output that is to be generated. Syntax analyzer. In the syntax analyzer, the that is to be tree generated is equal to right side we are having identifier 1 and this side plus left of this one identifier 2 and this star identifier 3 and then 60. Now this is processed with the semantic analyzer. Semantic analyzer. In semantic analyzer, the code once again that is to be evaluates that corresponding notations and then it is given by the identifier 1 plus identifier 2 and this is star operation left of this identifier 3. And this portion of the 60 that is into to float. It resolves the float and integer values and then generates the code. This structure can be sent to the next phase, that is intermediate code generation. Intermediate code generation. This is sent to the next phase, that is intermediate code generation. In this phase, the temporaries are allocated. That means into to float. This one description. Into to float of 5. Then T1 that is to be assigned with 1. Then T multiplication, that is what is identifier, that is ID 3. Identifier 3 star previous value is T1. So that is assigned with some T2. Now this T2 plus another identifier, identifier 2 plus T2, we'll getting the T3. Now T3 is to be the final value which is stored. So identifier 1, finally identifier 1. So that is identifier 1 is total, identifier 2 is count, identifier 3 is rate. So we are going to retrieve the 3 identifiers values with the using the temporaries T1, T2, T3. Now final result is stored in T3, that is identifier 1, which is stored as result T3. In this, it displays the result as intermediate code generation. One, this is given as output to the next phase, that is code optimization. Next one is that is phase generated code optimization. In this phase, the code that is to be reduced to the compared to the previous lines of code. Now how it will be reduced? Now identifier 3, that is rate star 60.0 directly it is written 2 statements combined into 1 statement. Previously I have written as a 2 statement into float of 60, identifier 3 start to T1. So these 2 statements can be written simply with as a 1 assignment. Now this is to be added with identifier, 1 identifier T1. So we are going to, this is to be assigned T3, once again T3, but here now directly we will assign to identifier 1. So based on this 4 line of statements which is to become closer with a less lines of code as, so that the result is to be same to the compared to the previous line. So even though if you break down the lines into several into small enough lines of code, but the output doesn't affect the remaining statements of the program. So that's in that way we are going to choose different temporaries which has been used by this intermediate code generation can be cut down into several lines into a smaller lines of code so that the result would be the same. And then these lines of code will be carried to the next further last phase of the comparison, that is code generation, where the machine code is to be generated actually, and that is the assembly instruction format where it uses the several instruction. So here we required identifier 3, so we are going to use a notation, so that is a move identifier 3 is to be this identifier is to be stored in one register, that is a say R1, say that is a register with an identifier, that is identifier 3, say for example here identifier 3. Now we are going to multiply this with the constant, so that result is to be stored R1, this is that is say register is to be stored with the multiply float. So we have here load F or move F. Now second instruction is multi F, where we are going to multiply the register value with who? That is constant 60. So that is which is written as 60.0, and the register is to be taken. Now we are going to take one more register for loading this one. So that is the load or move instruction, which is used for the loading this another register, say another register R2, which contains the information identifier 2. Now we are going to add this one with the, that is add instruction. Add is the another instruction, add A floating. Then the what is the registers that is to be added. Here we are going to add R1, say R2, and the result is stored. So that R1 is to be, previous one it is already loaded with R2. We are going to get the multiplication result R1. So that R1 plus and this R2 both are to be added. We will get the result, and this result stored in R1 will get the store STF, store accumulator. They store the content. So identifier 1 R1. So that is the final result which is to be stored in identifier 1. So in this way we are going to verify the result. So the contents, all the things which are available from this is to be available in the book. That is, this is the another problem. Like this, we are going to work out with the several phases of the compilation process. Thank you. We'll come up with the next problem with one more session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.